Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at the µBITX, which is an open source HF amateur radio transceiver from 1 to 30 megahertz. You can buy the kit or you can simply get the information and build one yourself. And they're quite interesting, not least because they were designed by an Indian radio amateur, original intention being to provide Indian radio hams with a fairly cost-effective way to get some HF radio equipment. It's a QRP or low power transceiver, and depending which band you're operating on, it gives you around about 10 or 15 watts, something like that, which is actually more than capable of working some decent distance, as long as you have a good antenna and you pick your moment and pick the place that you're going to operate. So let's start by having a look at a few obvious questions around the radio. Let's have a look how the design works, and then we'll see how she operates. Okay, let's start with exactly what the µBITX actually is. It's a high frequency, low powered transceiver working between 1 and 30 megahertz. Here's a picture of the front panel with the stock display, and as you can see, it's quite a nice looking bit of kit, very simple layout, but quite a lot of facilities considering what you're paying for this. I paid about £152 UK, and if you're prepared to wait quite a few weeks for the Indian Postal Service, you're probably going to get away without paying any import duty. If you pay some additional to get DHL to get it to you quicker, mine took about a week, you will end up paying a little bit of import duty. But there we go, it's still a very reasonable price. It's a completely open source project. All the circuit diagrams, information about the inductors, winding the toroids, etc. is all fully available, so you don't need to buy the kit. You can get you building your own circuit board and just use this as a basis for something else if you wanted to. It's very much an experimenter's baseboard, if you like. It's designed by an Indian radio amateur, Ashraf Anand, Victor Uniform 2 Echo Sierra Echo. And originally, I think his plan was to produce something that was reasonably priced, that would be affordable for Indian radio amateurs. And it's gone through a number of iterations, and we're at version 6 now. It's got excellent community support. I cannot begin to tell you just how much information is available for this radio. That's got a connotation which I'll come on to in a moment or two, but there is lots and lots of information out there. You arguably might say too much sometimes. The basic kit requires simple assembly, and if you're fearful of the soldering iron or fearful of wiring things up, no need to worry here. This is very easy to build with simple tools, a crosshead screwdriver, a pair of pliers, probably just about all you need to put it together, but we'll show you what the radio looks like in a moment. A company called HF Signals produce the kits should you want them, and you can buy a kit with a box or a kit without a box. It's got a level of sustainability to it. This is a quote from the HF Signals website. I'll just read it. HF Signals is a small enterprise based out of Hyderabad in India that works with a collective of workers. Each of the toroids is hand wound. This provides these working women with a livelihood. So it's actually quite nice to know that a little bit of good is being done in such a populous country as India. So a nice level of sustainability, I feel. You can use it as is, or you can modify. There's a few considerations worth bearing in mind. And I'm going to start by the use basic kit as is. Absolutely, my radio, I assembled the kit, put it together, connected it up, and it worked straight out the box. The kit comes fully tested, and there really is nothing more that you need to do. It works, and if that's all you need, then fill your boots. That's ideal. It's a QRP rig, low power. So it isn't a pilot buster. Don't expect to work some exotic DX when you're competing against half a dozen Italians. It's not going to happen. Pick your moment, find a quiet part of the band, use the QRP regions of the bands, and don't be afraid to if somebody's calling CQ and they've had no replies yet, that's possibly your opportunity to get in there. So yeah, it's a low power radio, but it doesn't mean that that isn't still going to get you around the world. Certainly, I know plenty of people have got them working in data modes and they're doing very well with them. It's worth making the effort to engage with the µBITX support groups. There was somebody had messaged the support group asking if there was some kind of concise index because they were finding it a bit bewildering, and could somebody help them. And the answer to their question is there isn't a simple index. Maybe if you're going to get one of these kits, maybe you could make that your project. Maybe I should make it my project. But you do need to make quite a bit of effort to really understand what's going on. There is a video that Ashar has produced that allows you to helps you to put the kit together, and if you just watch that video and assemble your kit, you're away and it will work. If you want to get a bit further into it, you do need to make a bit of effort, and there is a bit of a learning curve, because what you have to bear in mind is that a lot of the information out there will be for some of the earlier versions, and I think there were some significant changes around version 4, and with that in mind, there's certainly some of the earlier models had a reputation for spurious emissions, and that's now been much improved. Certainly I know version 5 and version 6 have a set of relay switched low pass filters in the output. Right, let's take a look at the architecture of the radio at a high level. So what you've essentially got is a double conversion superhet receiver and a transmitter, and I've put those in the same box with a dotted line because there are several bits of the circuit that are bidirectional. In other words, both receiver and transmitter use bits of those circuits boards. You've obviously, for the receiver, you've got an antenna at the input and you've got a speaker at the output. There is provision for a headphone jack. The transmitter has a microphone or Morse key input. This low pass filter, which I've shown separately there but is in fact on the main board, and there's obviously a switch to switch between transmit and receive. The board doesn't have its local oscillators or a BFO, so both the first and second local oscillator and the BFO are all fed into the board from a separate daughter board, and on that board is the PLL synthesizer chip. It's the SI5351A, and that has I think it's a 25 megahertz reference crystal, and that chip produces the 3 synthesized frequencies at a high degree of stability. That chip's controlled by a microcontroller in the case of the radio and Arduino Nano, and I2C instructions are fed to the synthesizer chip by the microcontroller. Additionally, there's 1 or 2 bits of switching logic that go direct from the microcontroller to the board, and there's a multi-pin socket that connects the board to the main board. There's a rotary encoder which feeds information into the microcontroller, and there's also a display. And the stock model, the display simply displays what the Arduino puts out to it, and it's a fairly simple, it's completely effective and readable display. So that's the basic layout of the radio. The bits with the blue box round are all on the main board, and the bits with the brown box round are on what is called the Raduno board. I guess that's Radio Arduino. I confess it confused me a bit when I was first looking at these radios. I thought, I don't know what a Raduno is, and it's just simply the separate daughter board that contains the microcontroller, the synthesizer chip, and the display. It's no more than that. Okay, that's the high level layout. Let's now have a look at the outside of the case and what she looks like inside. So this is the µBITX, or µBITX as some people say, but it is really a U as in the micro symbol, and this is the full kit with complete with the case. As you can see, a very nice metal enclosure, all fits very nicely indeed. Got sockets here for the mic, for a key, for headphones, volume control, and then we've got the well, it's a selector, it's the tuner, it's also a push button rotary encoder. Display is here, a speaker sits on top, and then on the rear side of the case we've got 12 volt DC in, we've got USB connector, and the RF in and out is via a BNC connector. It's nice to see a good quality connector. So now we'll lift the lid and show you around the inside. Okay, this is the µBITX with the top cover removed, and speaker attaches via a socket to the main board in there. Now I've got some modifications already fitted to this radio, so I'm going to ignore them at the moment. I'm going to do a video and talk about some of the mods I've done. So the main board, which is this green circuit board you can see on the bottom, just going to position it like that actually because it's easier for it to sit. So we've got, as you can see, plenty of toroids. Here are the low pass filters for the output, the PA FET output, PA semiconductors are there, driver stages are there, and then here you've got various service mount components. Don't know how well this is showing up on the video. Here's the crystal filter for the first IF that gives you that's the SSB filter, which in my experience works pretty well really. So that's the main board, and everything is on there except the oscillators. And then you have to forgive me because that bit of additional circuit board there is something I've fitted. I'll talk about that later. This board here is what they call the Raduno, and if I unplug this USB lead, that's just a USB extension that takes the USB out to the back. Here you've got the Arduino Nano, which is the brains of the unit. It has a USB port there, and it's plugged in using pin headers, and then the synthesizer chip is also on this board. So there's a multi-pin connector along the bottom that takes the various signals. Well, it takes the power from the board onto here, but it also supplies 3 oscillators, 2 local oscillators and the BFO come off here onto the main board. This heatsink here is for a 5 volt regulator, as this board contains the processor and also the display, which is also sandwiched to that board. So that's the insides. Here's the rotary encoder. The DC in simply comes through a hole in the panel, and as you can see, it's done a very nice job there of a circuit board mounted BNC, so we don't have to there's no loss involved in getting the signal off the board onto the out to the connector. And I'll just reinsert the USB, and you can see there that USB extension allows you to access the Arduino, whether that be for reprogramming, and also you can actually, depending on which version of software you've got on here, you can actually control this with software on a computer. So nice little enclosure. And for those who are perhaps fretting, oh well, it's a kit, you need a crosshead screwdriver for these various crosshead screws. You need a couple of small flat bladed screwdrivers to tighten the pins up on the connectors up on the tuning and the volume control knobs, and you need either pliers or a small spanner, just enough to tighten up a couple of the front panel hexagon nuts, like that as an example there, and that really is it. It's no more. If you can assemble flat pack furniture, simple flat pack furniture, you can put this together. And the case, I really think is worth the money, to be honest. It fits together very nicely and provides a good shield for the radio. So now we'll have a look at the radio in action. Okay, so I've got the radio connected up to 12 volts. I've got attached to my doublet antenna. Just a comment or two about the mic that comes with it. It's actually a Bofang speaker mic, but they've put a different connector on. It's got a stereo 3.5mm jack plug. Tip is audio, ring is PTT, and sleeve is ground. It's not connected, but there is a speaker inside there, so you could do some mods there and perhaps put a different connector on if you so wished. Now I'm going to switch it on. I've got it currently set in the 60 meter band. The display I want you to ignore. The actual display that's on the stock radio looks a bit like this picture here. It's perfectly adequate. I've made what's quite a common mod to the display, which I'm going to talk about in a future video, so don't worry too much about that. Okay, so I'm on 60 meters there, and I'm just going to change the just going to change the step size to 500 hertz, so it's a little bit easier to tune. So this is a station in northern Scotland. He's actually on the north coast of Aberdeenshire, so that's several hundred kilometres from me. I can't hear the other station, but then that's 7 megahertz. So I'm going to hop up onto 20 metres and hopefully should find something up on 20 perhaps. Just because I want to find something I can't. Yeah, it's pretty typical, isn't it? There's normally plenty of things, but not today. Let's just try 40 metres. Sounds a bit Italian to me. So I'm just tuning up in 500 hertz steps. Skip's obviously good for Italian stations this time of day. There we go, that's a bit stronger for you. Okay, well hopefully you're getting the idea of how well she works. What I'm just going to do now is I'm just going to move on to the HF air band, because I know I can get a strong station there so you can hear the audio. Let's listen to Shannon Volmet, which is on upper side band 505.
Visibility 10 kilometers or more. Light rain showers. Cloud few at 1,400 feet.
Now I'm not sure how well you can hear that through my tie-clip mic, but audio from this top mounted speaker actually is pretty good. It's certainly very comfortable to listen to. So obviously she works upper and lower sideband no problem, and she will also receive AM. So if I can find the BBC World Service for you, it's just a little easier for me to say. Nothing there at the minute. So that's AM, and that's AM in the 41 meter band. So what you need to do with AM is you need to beat it exactly onto the carrier frequency, and then you lose the heterodyne. So if I go back onto onto 100 Hz steps, you should be able to hear it. Obviously that heterodyne vanishes as you come bang onto frequency. Now the stock radio doesn't really have much of an automatic gain control. In fact, it doesn't really have any. That is a mod you can do. So that involves you sometimes turning the knob to adjust the volume, which is no great hardship. Probably will do an AGC mod at some point, but I haven't done yet. So not only does it receive and transmit upper and lower sideband in HF, it's also a perfectly acceptable general coverage receiver for the HF bands. So if I'm sounding impressed, that's because I am. Okay, so what I've done, rather than attempt to get a contact here while I'm videoing, is I've done some power output testing. I've used a scope to make the measurements. I've fed the transceiver into a 50 ohm dummy load, and I've used a two-tone. I've got a video on how I do the two-tone test, which I'll put a link to just up there, and I've used that method for this. So let's now have a look at the results I got for that. Here are the results of the output power then for the µBITX, and peak envelope power on the left and the bands along the bottom. As you can see, pretty healthy output for some of the longer wavelengths. Starts to tail off a little bit beyond beyond the 17 meter band, and it's just below 4 watts for 10 meters. So tying that up with the DC input power, and you can see that's sort of tracking the output power, something like anyway. And although it appears to be drawing well over 30 watts on the 80 meter band, do bear in mind of course that that's the transient peak, and the actual power used, average power used, will be far less. So if you're going to use this rig out in the field, a battery will I'm sure give you plenty of good service. And onto the spurious emissions, and to measure the spurious emissions I got the scope set up in FFT mode, and then I got it to identify the harmonics for me and plot those in a table. Here's an example from the 40 meter band, and you can see the second harmonic is 60 dB down, third harmonic 49 dB down. I won't bore you with a whole set of those. Let's see them in a table. And here you can see there's nothing that's less than about 46 minus 46 dB below the fundamental, so that's more than adequate. And some of the earlier problems with spurious emissions from some of the earlier versions of this rig have clearly been sorted out by the use of the low pass filter network on the output of the PA. Okay, well that's about it for part one, so to speak, of the µBITX. We've looked at the stock radio, looked at its design principles, looked at what it's like and how it works. I'm very pleased with mine. I've already, as I mentioned, made a couple of modifications, and I'm going to do a follow-up video where we'll look at those modifications. You don't have to do them. The stock radio arrives tested. You just assemble the components and it will work straight out of the box, so to speak. But if you want to do mods, it's an ideal platform for that as well. It encourages experimentation, and I actually really like that. I'll put links to where you can get the radio. I'll put links to the various support groups down below, and you can maybe go and explore them and see what you think. But seems a thoroughly worthwhile project to me, so well done to Ashar for coming up with this, and well done to the thousands of people around the world who support it and have done extra work to produce software and additional features for the radio. Hope you've enjoyed the video. If you have, please click the thumbs up. If not, you know what to do. Either way, thanks very much for watching. It'd be great if you could subscribe, and we'll see you on the next one.